Hi, how are you? Today let's talk about a metric or a measure called R squared or the coefficient of determination. Well, what is the R squared? Formally, R squared is defined as the amount or the proportion of variance in the dependent variable that can be explained by your model based on the independent variables that you have in your data. What does that mean? Well, it doesn't mean much. It's a working definition, and now we'll have to go ahead and look at the mathematical formulae behind R squared that might make things more clear to you. And if that doesn't help, we will also look at a plot that explains the concept, and for some of you, that might explain the concept. And finally, and more importantly, we'll actually see how exactly is R squared calculated. We'll use a toy example containing a small amount of data. In this case, we are going to see how we can predict the price of a house given two different variables, and we will calculate R squared for that example. So let's go ahead and get started.
With trying to understand R squared in more detail, we are going to look at R squared using three different points of view. The first one is the plot-centric view. The second one is the math behind R squared. And then we are going to see how R squared can actually be calculated using some data and using your Excel worksheet. So what does the plot tell us? Well, we are trying to predict the Y value from the X value, which means that we have one dependent variable, the Y value, and just one independent variable, which is the X value. And please remember that R squared is formally defined as the proportion of variance in the Y value that can be explained by our model based on the X values. Okay, and one way to predict value of Y is simply to calculate the mean of the Y values and simply put a line there. So this is the mean value. So if you get a new X value and they ask you to predict the value of Y, what you will simply do is that you will take the mean value of Y from the training data and say that, hey, this is my prediction for the Y value corresponding to the X value. Okay, but this is how the data actually lies. So the goal for you is to come up with a line that can run close as possible to these points of data, and that does a better job than this line that represents the mean. Okay, so that is the plot view of R squared. Now let's go and take a look at the math behind R squared. So R squared is formally defined as R squared equals 1 minus SS res divided by SS start. So what is SS res and what is SS start? Well, here you have those definitions. SS res is the sum of squares of the residuals and is formally defined as sum of yi minus y hat squared. So yi is y for each row and yi hat is the predicted value of y for that row. So what you do is you subtract the actual value of y from the predicted value of y and then square it so that you get rid of the negative sign. And then if you have a bunch of rows, just take a sum of all those values and you get SS res. Okay, and this predicted value of y can come from a linear regression model, or it can come from your random forest regressor, or it might come from, say, a deep learning model. Okay, so whatever the model is, the yi hat represents the predicted value of y. And SS start is the case where you have the actual value of y and you have the predicted value of y, and here we are actually using the average of all the y's in that data set to get the prediction of y. Okay, so the predicted value of y is the same, it's just the average value of y that you are taking, and then you are squaring it to get rid of any negative signs there, and you are taking the sum for those bunch of rows, and then you get SS start. And then if you plug these numbers in this formula, you have R squared. Let's go ahead and take a look at the calculation. How exactly can you calculate R squared? How do you actually use this formula? Here you can see a data from 5 different houses, and this is column number 1, which talks about how large is the house, which is the house size, and this can be x1, the first variable. And the second column talks about the walk score of that house, and this is x2. And the third column tells you the price that the house last sold for. So please multiply these numbers by 1,000 to actually get the actual value of that house in dollars. And as you see, the mean value of all these 5 y values is actually 442. So this is y average, the value that you see here. That's mean. Okay. And this is predicted y from our random forest model, or it can be any other model. And let me remind you, these are not actual predictions. This is just a toy example, and I have not used any kind of a model to actually predict those values of y. And this is what we are going to call as y underscore hat 1, y hat 1. So this comes from, this value of y, or the price of the house, comes from a random forest regression. Let's assume that it comes from a random forest regression model. And this is the predicted value of y, called y hat 2, and we are simply copy pasting the mean value of y from the training data here. So everything is 442. Okay. So let's think about calculating SSRes. So SSRes is sum of y minus y hat 1 squared, right? So y minus y hat 1. So this is y 300 minus y hat 1 is this. So 290. So 300 minus 290 is 10, and 10 squared is 100. That's what you see here. And you do the same thing for all these rows. And then you calculate the sum, which is equal to SSRes, which is 2600. So SSRes equals 2600. In the same way, you can calculate y minus y hat 2 squared. So y is 300 in this case, minus y hat 2 in this case is 442. So this is 142 squared, and this is what you get. Okay. And in the same way, calculate y minus y hat 2 squared here. So do that for all the rows, then add them up, and you get 67,680. That is SS tot equals 67,680. And plug these two numbers in this formula, and you get the r squared. So r squared equals 1 minus SSRes divided by SS tot, and we get a great r squared of 0.96. And remember, the best r squared is 1, and 0 means that your model is doing only as well as a model that uses the mean value to actually predict the y value, right? So if SSRes and SS tot are equal, then 1 minus 1 is equal to 0. So that means that your model is only as good as the mean model. So, I mean, it's not bringing in any value. And if your model is performing worse than the mean line, then you will actually get negative r squared. So the r squared can range from negative, a very, very large value, which if your model is really bad, to 1, which is the perfect value, which means that your model explains all the variance in the dependent variable based on the independent variables that you have. And an r squared value of 0 means that your model is only as good as a model that uses the mean of y to predict the value of y. So I hope you understood what r squared, or the coefficient of determination, actually means.